Hello friends, I Agrawal is Assistant Professor in Civil Engineering Department, Sandipani Technical Campus, Latur. Today's numerical is based on the analysis of determinate pin jointed frame by Weisselberg method. Now the learning outcomes. A student will be able to understand the concept of Weisselberg, and also the student will be able to apply the virtual work method to find the deflection in the pin jointed frame. Now virtual work method, by this method the delta, that is the deflection, that is equal to the summation a small pi into capital Pi into Li divided by the Ai into Ei. So here this can be modified and rewritten as delta is equal to summation of pkl by Ae. So here the k is the bar forces due to virtual force, and the p is the bar forces due to the applied loading. Now this is our problem where the length of member AB is 6 meter and the height is the 4.5 meter, and the problem is the sectional area of the members are such that tension members are stretched to 60 Newton per mm square, while the compression member are stretched to 50 Newton per mm square, and the all members having the same modulus of elasticity, and that is the 200 kN per mm square. And here we have to determine the vertical displacement or vertical deflection at the joint B. So now first step is to calculate the DSI, that is the degree of static indeterminacy. So DSI is equal to in bracket m plus r minus 2j. Here m is the number of member, r is the number of reactions, and j is the number of the joints. So here m is the A, B, BC and the AC 3. So m equal to 3, and these are the reactions HA, RA and the RC. So r is equal to 3. So here j is equal to also the 3, A, B, C. So put this 3 value into our equation, and here DSI is equal to 3 plus 3 bracket complete minus 2 into 3. So that becomes the 0. So this frame is the determinate frame. Now next is the calculation of the reactions. So here we are taking the sigma ma equal to the 0. So clockwise moment is positive and anti-clockwise moment is the negative. So we are taking sigma ma equal to 0. So this 10 into 3 the clockwise, and RC into 6 is the anti-clockwise. That is why is the minus. So RC is equal to 5 kilonewton. So by symmetry we can say that RA is equal to 5 kilonewton. And we are taking sigma h equal to 0. So summation of all the horizontal forces equal to 0 here. So HA is equal to the 0 because there is no horizontal force in the frame. Then take a pause and question arise in the mind of the student, that is what are the different steps to analyze the frame. So steps are the same as per the previous problems. That is, the first step is to P analysis, that is to find the member forces due to applied load, and the K analysis is to find the member forces due to the unit virtual load. So first go for the P analysis. So these are the reactions RA and the RC. Here by the method of joint we are finding the member force in the frame. So by the method of joint we are finding the member forces. So considering the joint C here, and find the force in the member BC. So here we have to first assume the direction of the member force. So here toward the joint we are assuming the force in the member BC is the toward the joint. Now apply here sigma fx or sigma fy condition. So here we are applying the sigma fy condition. So sigma fy equal to 0. So vertically upward is the plus and vertically downward is the minus. So here resolution of this FBC is the FBC cos 56.30 is the horizontal, and FBC sin 56.30 is the vertically downward. So by this condition vertically upward is a plus, so RC is the plus and FBC sin 56.30 is the minus, because that is the vertically downward. So RC minus FBC sin 56.30 is equal to 0. Then put here RC is equal to 5. So we got here value FBC is equal to 6 kilonewton. Now next we have to find the member force in the AC. So FAC, here assume the direction of FAC, we are assuming the away from the joint. So this member is horizontal, so we have to take sigma fx equal to 0. Towards right is a plus and towards left is the minus. So here FBC cos 56.30 towards the right, that is a plus, and FAC is toward the left is the minus. So FBC is the 6 kilonewton. Put this 6 kilonewton into this equation. So 6 cos 56.30 minus FAC. So here we got the value of FAC is equal to 3.32 kilonewton. Then the force in the AB is the same as that of the BC. That is why no need of the calculation of the member force in the AB. By symmetry, we can directly write the BC force is the same as the AB force. So here the P analysis, final forces, the AB and the BC having the same directions and the same magnitude, that is the 6 and member AC is the 3.32. So member AB is the compression and member BC is the compression and member AC is the tension. Then go for the K analysis. Then again first step is to calculate the reactions. So we are taking here the sigma MA is equal to 0, clockwise positive, anti-clockwise negative. So here 1 into 3 is a clockwise, 1 into 3 is a clockwise, that is why plus, minus RC into a 6. So RC is equal to 0.5. So by symmetry we can say that RA is equal to also the 0.5. Then sigma, apply the sigma H condition here. So we got the value of HA is equal to 0 because there is no horizontal force. Then the K analysis, we have to consider one by one joint and find the member force due to this unit load. So initially we are considering the joint C here and find the force in the member KBC. Assume the direction of KBC toward the joint. Then apply the sigma fx condition or sigma fy condition. Here we are applying the sigma fy condition. So vertically upward is a plus and vertically downward is the minus. Then resolution of this KBC in the horizontal direction, KBC cos 56.30 and vertically is the KBC sin 56.30. But as per the condition, our sign convention, vertically upward is plus. So RC is vertically upward, so that is why plus. And this KBC sin 56.30 is vertically downward, that is why is a minus. So put the value of RC is a 0.5 here. So 0.5 minus KBC sin 56.30 is equal to 0. So KBC is equal to 0.6. Then we have to find the member force in the AC. So KAC here, we are assuming the direction of KAC is away from the joint. Now this member is horizontal, so consider sigma fx condition. Sigma fx is equal to 0, towards right is the plus and towards left is the minus. So by this here we can say that KBC cos 56.30 towards right, that is why is a plus, and KAC is towards left, that is why is a minus. Then put the value of KBC is 0.6 into this equation. So 0.6 cos 56.30 minus KAC is equal to 0. So KAC is equal to 0.332. So by symmetry, the AB member also having the same force and same direction, that is the 0.6. So this is the K analysis and the P analysis. So here in the K analysis, member AB is subjected to compression. Also in the P analysis, member AB is subjected to the compression. And BC also compression in the P analysis, also in the compression. And in the K analysis, member AC is subjected to tension. So same in the case of the P analysis. Now, as per our condition, a previously problem is given that the compression having the stress 50 Newton per mm square and the tension having the stress 60 Newton per mm square. So here this AC is the tension. AC is the tension and AB and BC are in the compression. So here we know delta B is equal to a summation of PKL by the AE, but here P by K, that is the stress is the given in the problem, area is the not the given. So stress is equal to P by A Newton per mm square. For the tension given is 16 Newton per mm square, and for compression a stress is 15 Newton per mm square. So member AB and member BC that we have seen previously that are subjected to a compressive stress in the P analysis, and member AC is subjected to tensile stress in the P analysis. So as per this compression and tension, we have to take the stresses directly. So here is a table that is the stress P by A, AB and BC are the subjected to a compression, that is why 50 Newton per mm square, and AC is subjected to tension, that is why is a minus 60. Length of the members are the 5400, 5400, and for AC is the 6000. And here are the force in the bar due to applied load that do not here in the calculations. Here we have to take only the stress in the calculations. So 6 and the minus 3.32. Now here important is the K, that is the force in the bar due to the virtual force. So member AB is a 0.6, member BC is a 0.6, and member AC is the 0.332, but is a minus. Now here our formula is PKL by the AE. Here P by K is already given, there is the 50. So here take the 50, then what is remaining is the K into L. So K is the 0.6 and length is the 5400 divided by the, now here remaining only the E, that is the modulus of velocity, and that is the given 200 kN per mm square converted into Newton per mm square. So that gives the value 0.81 mm. Same in the case of BQ because both members are the identical. Then go for the last number, that is here the P by K is the stress, that is the tension in the member, that is minus 60. So put here the minus 60 into the K, that is the minus 0.332 into length the 6000 divided by the modulus of elasticity. So that gives the minus is the plus 0.59 mm. So delta B, the summation of PKL by AE, that is equal to 2.21. So this value is a positive. It means that we are assuming that initially that deflection in the downward direction, that is the correct. Thank you.